Hi, welcome. Let's study today about rationalization. So what is rationalization? Before getting into the actual topic of it, let's study what are rational numbers, getting into our lower grades. So what are rational numbers? Rational numbers are nothing but what we've studied. They are numbers of the form p by q, where q is not equal to 0. So let's write down. Rational numbers are nothing but p by q, denominator is not equal to 0, and what about p and q? They are integers. So they are integers. Coming to the higher grades, let's little redefine what are rational numbers. So how will we redefine? Let's simplify p by q. What will I get if I divide or if I simplify p by q? I will get a decimal expansion. For example, we have 1 by 2. How much do I get when I divide it? Obviously we get 0.5. We'll take another example as 1 by 3. So what do I get when I divide it? I get 0.3333, and here you can see that the remainder is 1. It remains constant, and the remainder we never get 0. So therefore the decimal keeps on expanding, or the decimal keeps on continuing. Here, as we saw, the decimal ends with the remainder 0. Here it keeps repeating with the same number. It's not stopping, and it keeps repeating with the same number. So how are we going to define rational numbers based on these decimals now? I can either tell them they are terminating decimal expansion, or they can be non-terminating with recurring decimal expansion. Recurring means they are repeating. I can guess what's the next decimal expansion is. I can guess what's the next decimal number is, isn't it? So we're going to define the rational number in such basis on using the decimal expansion. What can we tell? Terminating or non-terminating with recurring decimals are rational numbers. Whereas coming to irrational numbers, any guesses? Yes, looking at this we can make guesses. They will obviously be non-terminating, but also they are non-recurring. That means the numbers or the format of the numbers decimal expansion is non-repeated. We'll see what's that. Okay, so numbers which have non-terminating and non-recurring decimal expansion are nothing but irrational numbers. So here we have few examples. Root 2 is 1.4121. Can we see an end to this? No. Therefore they are non-recurring. And can we see any repetition of any numbers? I mean a particular pattern? No. So therefore it keeps on expanding. Similarly, root 3. We can take the example of pi as well. So what does that expansion is? 3.1417. It keeps on continuing, isn't it? So therefore irrational numbers are numbers with decimal expansions which are non-terminating as well as non-recurring. Okay, now coming back to rationalization. Why do we need rationalization? What is rationalization? We'll take examples. Suppose I have a rational number 1 by 2, a best example. So in the denominator what do we have? 2. That's a rational number again. So I can easily divide and tell it's 0.5. And the other example we had taken 1 by 3. This is also a rational number 3. So I can write 0.333. Yes. Whereas when I take 1 by root 2, how will I divide it? Because the decimal expansion of root 2 is 1.4147, keeps going. We don't have a fixed number here, so how will we divide another number? Whereas in rational numbers, suppose I take 1 by 0.5, so I can easily find out what's the answer, isn't it? But here it is not stopping. Therefore we're going to slightly simplify whatever is given when we have irrational number in the denominator to get another irrational numbers. Obviously, when we divide any number with an irrational number, we'll get back another irrational number itself, but we want a perfect answer. So what do? We use the method of rationalization. Okay, now let's see what rationalization is. Here, the process by which a fraction is rewritten so that the denominator contains only rational numbers. As I said, division can happen only when you have rational numbers in the denominator. So what will we do? We will rationalize it. For that, we need something called as rationalizing factor. What is a rationalizing factor? Now, suppose I had taken the example of 1 by root 2, isn't it? I need to multiply some number to this so that I am going to convert the denominator into a rational number. Obviously, we know when I multiply it with the same number, root 2 into root 2 becomes root 2 the whole square. Square and the square root gets cancelled and I will get 2 as the answer. But whereas to introduce this, I need to multiply numerator as well as the denominator with root 2. Therefore, I get root 2 by 2. Now, the number which we multiplied is very important, and that is called as rationalizing factor. So when we are working out problems on this, we need to work it out stepwise. First, we need to identify what's the rationalizing factor of the given sum. So what's the rationalizing factor? If the product of two surds is a rational number, then each of the two surds is a rationalizing factor of the other. Okay, as we already came across it. So shall we work out this example? So what is the question? 2 by root 14. What is our step 1? We need to find out what's the rationalizing factor. What is in the denominator? Root 14. Therefore, we will take another root 14. We will multiply and divide. So that's going to be our rationalizing factor. What is the step 2? We're going to multiply and divide, or we're going to multiply the numerator as well as the denominator with the rationalizing factor, root 14. How much do we get? 2 into root 14 is 2 root 14 divided by root 14 the whole square. So we get 2 root 14 divided by the square, and square root gets cancelled. So we will have 14. I can further simplify this. 2 1s is 2, 2 7s is 14. Therefore, my final answer would be root 14 by 7. Now I can simplify this further, but that's not our concern. We only need to rationalize the denominator. That means we're going to make the irrational number in the denominator to rational number. Hope you've understood this. Understanding this, we'll get into another, a little broader sum. Now what does this sum tell? 3 plus root 5 divided by 3 minus root 5. So obviously I have an irrational number in the denominator. I need to rationalize this. What are they asking you? If both a and b are rational numbers, find the value of a and b. So to find out this answer, I need to simplify this. Now, what's our step 1? Our step 1 would be to find the rationalizing factor. Now, what's the rationalizing factor? What do we have in the denominator? We have 3 minus root 5. Now, suppose I multiply 3 minus root 5 itself. Let's take this as a working column. If I multiply with the same thing, I will be left out again with roots, because this is a minus b into a minus b. What do you get? A minus b the whole square. So again I will be left with, what's the answer for this? ab plus b square. Here b, again I will be left with another irrational number. Therefore we will not take this into consideration. How will I simplify this? What do I need? I need square of this, isn't it? So always when I multiply with the opposite sign in between, I will get a square. Why? We have an identity. A minus b into a plus b is what? A square minus b square. I am not left out with any b term anywhere, so I will not get any irrational number. Getting back to the sum. So what will be the RF of this? So it will be the opposite sign of this. Always we can take it like that. Always when you have more than two terms, more than one term, this identity would hold good. Okay. So now what's our step 2? We will rationalize it. We will multiply and divide with 3 plus root 5 divided by 3 plus root 5. Now let's simplify this. What does the denominator become? A minus b into a plus b is a square minus b square. What's in the numerator? A plus b into a plus b, isn't it? So we have 3 plus root 5 the whole square, or you can use the distributive property and multiply it. So what do we get? A square, that is 3 square, plus 2 times ab plus b square divided by a square is 9 minus this and this gets cancelled, 5 is remaining. How much do we get? 9. This is 9. Okay. 9 plus 6 root 5 plus 5, because the square and the square root gets cancelled, divided by 9 minus 5 is 4. So how much is 9 plus 5? We'll all simplify all the like terms. 9 plus 5 is 14 plus 6 root 5 divided by 4. What's common in the numerator? 2. 7 plus 3 root 5 is inside, divided by 4. 2 1s and 2 2s. So I have 7 by 2 plus 3 by 2 root 5. Okay. Now let's compare the given question with this. So what's in place of a here? We have, what's in place of a? We have 7 by 2. Therefore I will write it here. A is equal to 7 by 2. And what's b equal to? 3 by 2. When we are comparing both the final answers, we cannot further simplify this. Yes, we can simplify it using multiplying root 5, but yes, well, that's not our concern. We will stop it here. So hope you've understood. We have a lot of application part or applicative questions coming up for your exam concerned point of view. So hope you understood this. Thank you.